Hello everyone. Today in this video we will be covering alkanes. Now alkanes follow a general formula, that is CnH2n plus 2, and an example that we can see is that if N is 1, then the alkane produced would be CH4, and this is given the name of methane. If the N value is 2, the alkane produced would be C2H6, which can also be written as CH3 and CH3 in the form of two methyl branches, and this is called ethane, and so on. It goes on like this. Now, another point to notice about alkanes are that they are saturated hydrocarbons. What do we mean by that? We mean that they have only carbon-carbon single bonds. A double bond or a triple bond between the carbon atoms does not exist. They only exist as single bonded carbons, and that is why they are called saturated hydrocarbons. Another point is that alkanes exist as straight chains or cyclic forms. An example of this would be to take any alkane. I am going to take hexane over here, C6H14. Now, one way to write hexane would be to write it like this. This is one way to write it, and this is the straight chain form of it. But another way to write it is in the cyclic form of hexane, and that is going to look like this, right? And cyclohexane is the name given to this. Okay, now these are the basic points about alkanes that we need to know. Now moving on to the physical properties of alkanes. What exactly the physical properties are? Let's go over those. Now, physical properties of alkanes cover the fact that they are non-polar. That is a very important point. They are non-polar. Why? Because they do not contain any dipole movement, and there is no measurement of polarity in this, in the sense that there is no overall dipole. Okay? And that is why all hydrocarbons are non-polar, and specifically alkanes are always non-polar. What intermolecular force they contain is instantaneous induced dipoles, which can have a short form IDID, or temporary instantaneous induced dipoles. Now, what about the states in which these alkanes exist? Now, they follow a pattern, okay? The beginning alkanes, meaning from carbon 1 to carbon 4, they follow gaseous patterns, okay? They follow gaseous patterns, okay? Now, after that, from carbon 5 to carbon 16, we have them in liquid state, okay? And then above carbon 16, meaning carbon 16, 17, 18, carbon 20, and however large the alkanes can become, they will be existing as waxy solids, okay? Now, this is an established fact, but what if we talk about other physical properties such as the melting point and boiling point? Now, since the state is changing from gas to liquid to solid, the melting point and boiling point will increase as the number of carbon atom increase. Okay, the density will also increase. Why? It will increase because the molar mass is increasing. As the carbon atoms increase, the molecule of the alkane is getting larger, and since it is getting larger, the molar mass is increasing, and since mass is increasing, the density will increase. Then viscosity will also increase. Viscosity will increase simply because the instantaneous induced dipoles that exist in the alkanes are getting stronger, and they are getting stronger again because of the increased number of carbon atoms. Moving on to volatility. Now, the volatility will decrease. It decreases because the boiling point increases. Since we know as a fact that a substance is more volatile if it has low boiling point, and conversely a substance is less volatile if it has a high boiling point. And so we can see the pattern being followed in this alkane series. Now, what about vapor pressure? The pressure that is created by gases. Obviously, since ID-ID forces, instantaneous induced dipoles, are getting stronger, that means that the vapor pressure is decreasing because a gas is getting converted to a liquid which is moving on to become a solid. So these are the patterns that you see in these physical properties. Okay. Now, before we move on to the chemical properties of alkanes, we will see and try to study where alkanes actually come from. Okay. Now, the sources of alkanes that are specific to our syllabus is from crude oil. Okay. Now, I've attached a picture of the method of from where alkanes are brought about. But what procedure does this entire diagram follow? It follows fractional distillation. And fractional distillation obviously is a method of purification which is brought about by heating the mixture of compounds to a certain boiling point, which leads to separation of these compounds into their pure forms. And we can see that happening. Over here, we can see that first of all, the crude oil is put in from here into this heater, that is heated, and that leads to these fractions being produced. Okay, now these fractions are being produced, and first of all, since refinery gas has the lowest boiling point, that will be released at 20 degrees, then petrol will come out at 70 degrees, naphtha at 120, and so on and so forth, and then lastly bitumen will come out at 340 degrees. And along at the side you can see all these uses mentioned for these fractions of crude oil, that refinery gas is used for bottled gas, and petrol is used for vehicles, naphtha is used for chemicals, and lastly going on to bitumen, which is used for roads, roofing, and it is also used to make tar, which is used for roads, right? So now some of these uses you have to remember because it is asked in the examination. Okay, so you don't need to know the exact boiling point at which they are separated, but what you do need to know is at least one or two uses of each of the fractions, and you need to know in which order these fractions are separated. Okay, so this is the important part in fractional distillation of crude oil, which leads you to get alkanes. Now in the next video we will be going over the chemical properties and the reactions which alkanes take part in. Thank you.